professional. After his graduate program at Rensselaer Polytechnic Institute, and he points out a personal interview with Admiral Rickover, he enlisted in the U.S. Navy Civil Engineering Corps in 1961 as a nuclear engineer. He was assigned to McMurdo Sound, Antarctica, 1965, during the installation of the nuclear power plant there, and later to Fort Belvoir, Virginia, as officer in charge of the Navy Nuclear Power Unit. After he retired in 1981 with the rank of captain, Will joined the UF Civil Engineering Department faculty. For the last 7 years of his time at UF, he served as the College of Engineering Assistant Dean for Academic Programs, while also actively engaged in the Gainesville community. So I'm very pleased to introduce Will Shafer to talk about his years in Antarctica.
Good morning, everybody. Delighted to be part of the kickoff for the fall semester 2024 of ILR. And sure enough, we're going to be talking about Antarctica. This will be a quick trip, kind of an overview, and not a lot of detail, but a lot of Antarctica. When I talk to school children, I'm very fond of asking them, what is the largest desert in the world? And I very seldom get the answer, Antarctica. But I know that if I ask this group that question, you'd all get it right, correct? Why is that? Well, it's because in Antarctica, it's very barren, uncultivated, very low precipitation, very extreme temperature is recorded, and it has all of the dictionary definition characteristics of a desert. So Antarctica, for sure, is the world's largest desert. I'm going to cover about a 70-plus year time frame in Antarctica. We're going to start basically back in 1956 when the Navy was down there preparing bases for the National Science Foundation International Geophysical Year, which was 18 months long during the period 1957-58. So what does Antarctica have? It has penguins, it has seals, it has birds, and that's it, unless you bring it down there. No polar bears, no foxes, no indigenous people. Access is generally from October, 1st of October through February, and that's just the reverse of the Northern Hemisphere in terms of winter and summer. So that gives us 5 months of access to Antarctica and then 7 months basically with no access. During the 7-month winter over period, there have been very few emergency flights arranged to Antarctica, but there have been a couple. Today, we're going to cover with pictures an overview of the Antarctic involvement, basically from '56 to present, not with an emphasis on scientific, but more with an emphasis on what have we been doing down there in terms of facilities and people and that sort of thing. The total effort has been directed by the National Science Foundation, and they call that the United States Antarctic Research Project, and USARP. And that's very familiar with those who are associated with universities and trying to get grant money for work in Antarctica. The Navy initially, and I say initially, from the 50s to the 90s, provided all the logistic support for the National Science Foundation to be in or around in Antarctica. In the 90s, when the Soviet Union collapsed, the United States reaped a huge peace dividend and cut the military services significantly, and the Navy was no longer able to support the National Science Foundation. So they went to private contractor support. Also, for their inland South Pole flights, they use, you'll be surprised at this, the United States Air Force National Guard unit from Schenectady, New York, stationed at the Schenectady County Airport. Not many people would realize that. You may say, why? That's odd. Well, that unit had been flying for years, all the Arctic flights. And the Arctic flights are just the opposite time-wise as the Antarctic flights. So now they can be a full time. Summertime up north, Arctic flights, summertime down south, Antarctic flights to the pole, because they'll use the same aircraft, the C-130 ski-configured airplanes. Okay, most of the Admiral Byrd expeditions, which I'm sure our age group is familiar with, Little America, all four of their five were before 1956. And the fifth one was during Deep Freeze 1, which was corresponded with the IGY year kickoff. So I'm not going to go back to Admiral Byrd and Little America. Following the 57-58 IGY year, President Eisenhower convened the 12 signatory nations that were active in Antarctica during the IGY, and they drafted the Antarctic Treaty in 1959. The treaty was officially enacted in 1961, and I have a copy of the United States stamp that was issued in commemoration of that treaty up here on an envelope with a bunch of things on the table that you're welcome to peruse. Interestingly enough, that Antarctic Treaty was the first of its kind in the world to the extent of its cooperation and so forth, and it became the model treaty when the United States and Russia negotiated the Space Support Treaty. So, with that introduction, let's see what we have here with regard to the Antarctic continent. There we go. I was hoping for the headset so I could wander up in front of the map with a laser, but we'll try it from here. Okay, we'll do it with voice directions. There we go. Okay, this is the Antarctic continent. The shaded line, the furthest out from the center of the map, is the Antarctic Convergence Zone. That's where the very cold waters of the Antarctic Ocean go underneath the Atlantic and the Pacific and the Indian Oceans. And it's quite a turbulent zone if you're passing through it with a ship. And then you get closer to the continent, you see the continent outline. I want to start from the bottom there. There's a note that straight down is New Zealand. And if you want to get to Antarctica to the U.S. bases, McMurdo and South Pole, you first go to New Zealand. And then the feature, when you reach the Antarctic continent that's closest to New Zealand there's a cape called Cape Adair, and we have a weather station on that cape that we maintain during the summer. And you got to recall, I was in Antarctica 63, 64, 65. That was before satellites, and there was no weather. So it was absolutely important that we have that weather station between New Zealand and Ross Island. Now, as you go along the coast due south about 800 miles, you come to the edge of the Ross Ice Shelf. The Ross Ice Shelf on the right has an island, Ross Island, where McMurdo Sound Station is located. Over on the left, you can see there's an island. That's Roosevelt Island, and that's near where Byrd had his Little America Antarctic stations. The ice shelf is about the size of the country of France, and it's a beautiful highway toward the South Pole. And that's why Scott, Shackleton had their original huts on Ross Island so that they could go about halfway to the South Pole just across the Ross Island Sea. Then you hit the Trans-Antarctic Mountains, which are that dark shaded area there, and have to get up through the mountains. And the best way to get up through the mountains was use a highway. What's a highway through the mountains in Antarctica? It's a glacier. For instance, Shackleton went up Beardmore Glacier. And then you head across the polar plateau to the South Pole, which is only another 150 miles or so. Okay, at the South Pole, it's about 2 miles high, over 10,000 feet. And the coldest temperature up there is about 125 degrees Fahrenheit in the winter. Okay, so the South Pole's in the center of the map. Ross Island is where McMurdo Sound is. Those are two of the stations we have there today. Way over on the upper left, you see the Antarctic Peninsula. It's just below the tip of South America. And on the end of the Antarctic Peninsula, there's an Onders Island, and that's where we have Palmer Station, our third active station today. During the IGY year, we actually had 8 stations in Antarctica. And you can see if you look at all the area between Ross Island and around to Palmer Station, that's all under the Pacific Ocean, looking down. And then on the other side of South America over to Africa would be the Atlantic Ocean. And then around a little further, the Indian Ocean. And we've circumvented the Antarctic continent. Okay, let's just leave it there then. Hope I'm going in the right direction. Okay, as I mentioned, we get to Antarctica to our 2 main bases, South Pole and McMurdo Station, by first going to New Zealand. Get yourself there on a commercial jet. Then there's an activity run first by the Navy and now by National Science Foundation at Christchurch on the South Island in New Zealand. And what they do is they issue your clothing for Antarctica. Thermal underwear, wool pants, wool shirt, thermal boots, rubberized boots, and maybe some bunny boots, felt boots, heavy parka, scarf, that sort of thing. And then you stand by to be booked on a flight. Several ways of getting to Antarctica. This happens to be in the cargo hold of a C-130 Hercules. And these 2 young naval officers have their feet up on the cargo, and they're sitting in stretcher seats on the side of the plane. No doubt earplugs in place because it is really noisy. My first trip to Antarctica in 1963 was exactly like that, in a stretcher seat on a C-130 with my feet up on cargo. Here's a C-130 configured for cargo and people in another direction. Back in the 60s, there were no females in Antarctica. The facilities were kind of crude. But in recent years, last couple decades, there have been a lot of females in Antarctica. Here you see proof of that. Behind the stretcher seat barriers would be cargo, and these young ladies seem to be fairly comfortable. It's about an 8.5 hour flight in the C-130. The alternate Air Force transportation would be with the C-17 Globemaster, and you can see this one's configured 5 seats abreast, plus bench seats up and down the sides, and notice in the back of the plane it is jammed full of cargo. So if you're comfortable when you get down there, you can have a few hours of sleep. If not, you are glad you're there. Oops. There we go. Here's a C-17 about ready to land at McMurdo. In the background, you see the Trans-Antarctic Mountain Range, 11,000, 12,000 feet mountains. In the front, you see some lower foothills, if you will. Those foothills are about 40 miles away, and the air is normally so clear down there, it looks like you can reach out and touch them, but it's not a Sunday afternoon walk. Here's the C-17 disgorging its passengers. In the background, you can see McMurdo. Okay, let's look at McMurdo Base as it existed over the years. From the annual ice, which freezes every year about 5 to 8 feet thick, and by the middle of December, January, February, the ice goes to sea, and then we start all over again, late February, early March. To the left, in the rear, well, let's start way up high in the rear. That's Mount Erebus. It's one of the active volcanoes in Antarctica. It's about 12,000 feet high. McMurdo is right down in the front, in the middle. On the left is Hut Point, where Scott had his first expedition. And on the right is Observation Hill. And halfway up that hill is where our nuclear power plant was built. There's a better shot of Mount Erebus. Yeah, it's smoking steam all the time. This is McMurdo Station, 1956, right after the Seabees, Naval Construction Battalion people arrived. There wasn't much there, and they had to from middle of 1956 to early in 1957, they had to build a camp for the National Science Foundation. This is what the first camp looked like on the site that we just saw an aerial view of. Over to the left just a little bit is downtown McMurdo. You can see it was well organized, but this was it. The foundation of the buildings is basically crushed basaltic rock, volcanic rock, if you will. And about 98% of Antarctica is covered year-round with snow, but there's a little bit of space at the edges and on the mountain peaks that are not covered with snow or ice. Well, there we go. These are James Way huts. They were developed during the Korean War and used for summer support people in Antarctica. More about those later. This is Main Street, Antarctica, as I knew it in the mid-60s. At the end of the main street is Observation Hill. It's about 830 feet high, and on top is a cross dedicated to Robert Falcon Scott and his party, which perished on their return from reaching the South Pole. This was the first building built in 1956. It was a meteorological building. Remember, weather was extremely important to us. Notice about a third of the way, halfway up Observation Hill is a little plateau in there, and that's where the nuclear power plant was built. Another one of the first buildings was the Chapel of the Snows. This chapel burned down a few years ago, unfortunately. It housed a lot of artifacts of Antarctica. For instance, my crew's plaque was in there with our names and so forth. Out in the front yard, in November of 1964, they dedicated a bust of Admiral Byrd for his work in Antarctica. That has since been relocated after the chapel burned. We'll see that later. This is an aerial view of McMurdo, pretty much as it looks today. I know it's today because in the very bottom of the picture there, you see 5 parallel buildings right off the harbor. And those buildings are 2-story personnel buildings, kind of like Hilton's or Marriott's in Antarctica. And that's why the ladies are invited down there these days. Another shot of McMurdo, not too recent. 4 of the 5 buildings are there, but I want you to note in the lower left foreground, there's a building, and that was part of the nuclear power plant up on Observation Hill. In the background, off to the left, is Hut Point, and out on Hut Point is Scott's original hut from 1903. We'll see more of that later. At McMurdo, during the summertime, the base loading is about 1,000 people, and during winter over, 200, 200 and a quarter. Okay, here's a view from the other side of the camp, looking across the little harbor there over toward Observation Hill. Similar shot. This has a Coast Guard icebreaker, the Polar Star, in the little bay there, cleaning out the brash ice. This was probably late December, January, for the once-a-year supply ship to come in. There's the supply ship in the harbor, and if you need it, you get it once a year. You don't get it, you don't need it. McMurdo in the background. Lower left is Scott's hut, pretty much as it exists today. It's a national New Zealand historical site and controlled by New Zealand because New Zealand claims all the land where our base is built. But by the Antarctic Treaty, all sovereign territory claims in Antarctica are held in abeyance. I think no fewer than 7 nations claim the South Pole, none of which are the U.S. or Russia. But we're the only ones who have been resident there since 1956, and possession is 9/10 of the law. Okay, Scott Hut right there in the center of the picture, the town with some street lights on. And one day you realize the sun ain't coming up today, and then it's another 4 months of pretty dark. Okay, we've transitioned from days of old to modern days. You'll never guess what this building represents. Taxpayers, it's a wastewater treatment plant. We are living by the Antarctic Treaty. Here's the foundation for the plant, built up off the ground. Here's part of the inside of the plant as it was commissioned. And it provides primary and secondary treatment for dischargeable water back into the ocean for all the buildings and personnel at McMurdo Sound. When the National Science Foundation was there in early years, instead of having a wastewater treatment plant, we used 55-gallon drums. Put them on the ice and they went to sea. The current electrical power is from this 6-unit diesel plant. You'll notice from the stacks that 3 of the units are fired up. Why? Because the flapper valves are up in the air, the others are not. This is Antarctica as we know it today. The pipes are fresh water and wastewater between the buildings. The little wooden building in the center near the front with the peaked roof, the A roof, is called the Chalet. This was the National Science Foundation original headquarters in Antarctica back in the IGY years. In the early 60s, I was in that building a lot, and I've heard a number of really good scientists lecture there to other good scientists, and I learned about how penguins navigate by the sun. I learned all about, for the first time, the tectonic plate theory. And back then it was not well received by a lot of scientists, but today it is. The large building in the center is the current National Science Foundation headquarters and laboratory buildings. And you see in the background on the right are the personnel buildings. And McMurdo is quite a little city. I put this photo in because of the gentleman that's in the center of the picture. That's Sir Edmund Hillary. He led the first trans-Antarctic traverse by the UK back in the IGY period. And he was revisiting the Antarctic about 2009 or so and escorted there through the Chow Line. He was also famous for having climbed Mount Everest in the early days. Here's the porch of the Chalet. Remember I mentioned when the Chapel of the Snows burned, the bust of Admiral Byrd was relocated. They put it on the porch of the NSF Chalet. You'll see the flags of the 12 original signatory countries of the Antarctic Treaty, along with a historical marker there. And should you go to McMurdo, you'd probably want to visit this building. I know of only 2 historical monument markers there. One is at the site of the PM3A nuclear power plant up on Observation Hill, and the other one was here at the National Science Foundation Chalet. Ship out there's an icebreaker. Around back of Ross Island, about a mile and a half from our camp, is Scott Base. Scott Base is the New Zealand headquarters. And of course, they've been there since the IGY year. They have stamps issued that show their sovereign territory claims in Antarctica. And we're poachers on their land, if you ask them. What do you do during the long winter nights in Antarctica if you know how to weld? Little Antarctic sculpture. Okay, you've seen Antarctica, days of old, current days. Pretty nice facility. Don't hesitate to go down if you get the chance. Now we're going to look at the South Pole. We're coming in on a C-130 Hercules, and this is the ice landing strip, a little over 10,000 feet elevation. On the left are some scientific experimental stations. On the right is the South Pole camp area itself. There's the South Pole camp area. This is kind of a historic photo because in the very center of the photo, see that dark black half dome? That's a geosphere that was built for our third Antarctic camp. And over on the right is the current Antarctic camp that accommodates about 150 people. And I'll be talking more about both of those. All of their supplies are neatly arranged out on the ice, and I hope the supply officer knows how to get his hands on just what he needs when he needs it. Okay, bases in Antarctica. The first base, obviously, was a Munson's tent when he discovered the South Pole. The second base was Scott's tent when he showed up after a Munson was there, just a few weeks. And of course, Scott perished on his return trip. The third base was built by the Seabees in 1956, and there it is. Now, if you know much about Antarctica, you know it only snows an inch or two a year. But when it snows horizontally because there's about a 20 or 25 knot ambient wind. And anything you build down there is going to snow over in a year or two. So this base was active from 56 until about 75. And then we transferred to the geodesic dome. Here's the geodesic dome. I'm going to spend some time showing you the construction techniques for that dome because why? I'm interested in it. In order to construct the dome, we milled out a circumferential area, a circle, if you will, that defined the foundation location for the total dome. So all of the weight of the dome, including any ice that formed on it on the inside, had to be supported by this foundation. In the milled out area, we installed wooden foundation pads, which spread the pressure from the dome out over a large area, and then some tracking, which was a circumferential band around the dome to keep it from spreading out. That track was beefed up a bit, and then we started erecting the struts of the dome. This is a picture inside the dome during construction. It's looking out the front door, and of course through that door it was the only access, ingress and egress for all of the material that was brought inside the dome to build the fourth Antarctic station. Notice right in the center of the dome is a foundation for a tower. The tower was built the height of the dome, about 52 feet or so, and on top of that was put a structural ring called a compression ring, which all of the struts that were being built up to form the dome actually were attached to that compression ring, and that took all the stress from the dome inward. The struts were put together with two gusset plates, one on the bottom, one on the top, all bolting, no welding. And there's a view of the strut gusset assembly. And then up on the top on the left, you see the sheet skin, the sheeting that was put over the outside of the geodesic dome that was tied in with the gusset plates, and a spline to seal it between the sheets and the skin, and then a cover gusset plate to keep it all away from the weather, so to speak. The bottom there, you see a good cross-section view of how the panels, the spline, the gusset plates, and the strut were all put together. Here's a plan view. You can notice that's, 52 feet high or so, 164 feet in diameter. And there's the front door, the only way in and out. Every piece that was sent down to Antarctica to build this geodesic dome was color-coded. And when the people got it out of the boxes, you might say, they knew exactly which pieces to bring next to support the construction sequence. There's the tower erected with the compression ring up at the top, and you can see the struts are beginning to go up, and they've even put a couple of panels on. Here the structural network is completed. The tower has been disassembled, and the geodesic dome is freestanding. Here's the dome as the panels were being added, almost finished. There's a CB working, instructing the last panels. Notice he has thermal boots on. They're rubberized, very thick, warm boots with about 3 pair of socks. They do the job. Okay, 30 years later, here's the front entrance to the geodesic dome. The whole area had drifted over pretty much, and they had this tunnel, which they could keep the ramp free of snow, and this was the only way in. Here you see the relationship to the tunnel, the dome, and a couple of other auxiliary facilities that were beside it. Those steel arched roofed buildings where one was for transportation, the other one was for utilities, diesel engines. Here's an overview of the drifting around the geodesic dome. Remember that dome's 50-some feet high, and you see the snow's most halfway up it. So this would have been when the dome was about to be abandoned, and you can see way over on the right, down low, the beginning of the construction of the current South Pole Station. We'll be talking more about that in a minute. And you can see the 2 support buildings there in the middle. Drifting area around the dome. Here's inside the dome. This was the winter over camp, well, the total camp for many years. Notice it creates its own climate. What do you see up on the roof? Stalactites, icicles. I'd hate to be walking under those all the time, but anyway, I did remember that I had learned the difference between a stalactite and a stalagmite. Stalagmites come up from the bottom, stalactites come down from the top. So how do you remember? Well, those things up on the top have to hold on tight in order to stay there. Stalactites, okay, got it? These were the buildings, mess hall, dormitories, lab buildings, restroom. Okay, outside at South Pole were a bunch of these Jamesway huts, and here's where the summer support people were berthed. There's the Jamesway campsite. A Jamesway hut, as I mentioned, was really developed for the Korean climate during the Korean War. And basically there was a platform on the ground, wooden, up off the ground, wooden arches, or ribs, if you will, purlins between the ribs to give that structure stability, and then a heavily insulated waterproof blanket that went between a couple of the ribs and was laced to the previous blanket. And so they just built the blanket system on down to the last rib, and they put an end on it. I've slept in these Jamesway huts temporarily. I slept in about a 60-knot wind in one, and the blankets where they're lashed together, you could see the light through, and the stove in the middle had gone out because of the wind, and you really realize that the early settlers had it pretty rough. This is the boneyard at South Pole. There's the geodesic dome again and the new South Pole Station off on the right. Now, construction of the South Pole Station. Notice these hefty columns. They're telescoped so that the South Pole Station can be jacked up twice during its lifetime. It's about 20 feet between the ice and snow presently and the bottom of the station. So when that 20 feet gives out because of accumulation of snow, then we can jack it up. This is a good picture of the columns and the structure of the camp. Notice in the foreground there on the left, you see a sandwich up on the sawhorses of plywood and styrofoam, and quite thick. And you can see that same sandwich in the floor structure of the erected building. And just above that sandwich, you see a hefty airspace, dead airspace, or a space through which you can blow some warm air and keep the floor warm in the camp. And then these walls and the roof be the same material. You'll notice the station has 4 major wings, 2 stories high, and a continuous assembly on the front. The silver silo is where the utilities enter the building. Another view. You can see up in the upper left, you'll see one of the outlying scientific sites. There are a bunch of them scattered around the South Pole station. It was shot during final construction. Notice the snow ramp up to the back of the building. That, of course, is so that they can load all the furnishings in the building, construction materials, without having to lift it. Just a little feature that's productivity initiative, if you will. And then later on, with a bulldozer, we can disperse that snow. Here's the inside of one of the laboratory buildings being outfitted. Here's the smallest hospital in the world, 2-bed infirmary at South Pole. Here's the operating suite. If you take the ratio of beds to operating suites, it's got to be a pretty favorable ratio. Here are the 2 support buildings for surface transportation equipment and diesel power that had supported the Geodesic Dome camp and now supports the new camp. Okay, about a quarter of a mile away is the actual South Pole itself. 90 degrees south. There are the 12 signatory nation flags for the Antarctic Treaty. And off on the left is the United States flag and a sign. And near that sign is the pipe, which is in place, which is the actual South Pole. Over on the right there is the little pole. That's the South Pole. We have to move the South Pole about 33 feet every year. Ice has a plasticity characteristic, and the whole ice cap is shifting and moving, and eventually all this ice will go out to sea 800 miles away. And there is a shiny ball they mount on that pole when they're finished, and they're relocating the sign that tells about the South Pole, geographic South Pole. Ronald and Munson, Robert Falcon Scott, South Pole Camp, as it's named. There it is, completed for another year. Here's a good plan elevation view of the South Pole Station. And you see that 20 feet underneath will allow the wind that hits the station to either blow over the station or blow under the station. And the wind blowing under the station, we hope, will provide sufficient scouring to take the snow crystals right on by. And it's be interesting to see how many years it is before we have to jack the station. Okay, we'll leave the South Pole and we'll go to Palmer Station. This is on the Antarctic Peninsula, due south of South America. Some of you who have taken a cruise out of Chile or Argentina may have encountered people from Palmer Station. Anybody here go to Antarctic Peninsula? Did you get to Palmer Station? Yeah, about a half a dozen. Okay, in the background on the right is Palmer Station. In the middle of the picture is a glacier headed toward the sea. Here's a closer view of Palmer Station. And if your ship happens to stop near Anders Island, you hop in a Zodiac, you go aboard, they might give you a little lecture on their current work. I think it was Maddie that was telling me the other day, one of her friends from Washington State University had a research grant, part of which was carried out at Palmer Station. She had been to McMurdo, and she had decided that, she was going to send her graduate students to Palmer Station. Okay, transportation in Antarctica. Here are the C-130 Hercules planes that do all the inland flying with skis attached to their wheels. Here's a close-up view of one of the planes. They're 4-engine turboprops. Guess this plane's taken off, getting waved goodbye. During the IGY year, 57, 58, we used the DC-3. Navy called it the R-4D. You'll remember that old DC-3 passenger plane. I've flown on many a DC-3. This is the Nathaniel Palmer NOAA research ship, and it gets to the Antarctic regularly. Here's our annual oil delivery with a Coast Guard breaker Polar Star next to it. And in the background is the Nathaniel Palmer and a Russian icebreaker. It's kind of a pity that National Science Foundation has to rent Russian icebreakers every year because the United States is too cheap not to build their own. And we dearly need them, especially since the Arctic is becoming more of an area of interest for year-round transiting. But the Coast Guard has really been short-shifted and just has a couple of ancient icebreakers left. There's a tracked vehicle that's used to get field parties, scientific parties out into the field. This is a tracked vehicle that's used for pulling sleds and other logistics support. Notice the rubber treads are not only for traction, but they also spread the pressure of the vehicle over a larger area on the ground so they can stay above the snow better, don't depress so much. Low ground pressure vehicles, if you will. On the annual ice, which I say is 5 to 8 feet thick, we have to core it continually because we have 2 runways at McMurdo. One runway on the annual ice, and when it gets a little thin, we don't land airplanes on it anymore. And the only reason we can tell it gets a little thin is because we core it. Along about mid-December, that ice starts to crack. And by January, early February, it's all gone to sea. So in order to have continuous support during the 5 months summer support period, we have another runway back on the ice shelf, the Ross ice shelf, that's a couple miles back opposite Scott's New Zealand base. And the ice under that runway is about 120 feet thick. We don't bother coring that. Although I was there when we were trying to break through the 120 feet because we had built a restroom facility out there and we wanted flush water. And the only way we could do it is run a pipe straight down. We hit water at 120 feet. That's why I can say with certainty how deep the ice was. More core drilling. If you're going to be planning a traverse in Antarctica, you'd better reconnoiter it first and look for hazards like this one, which is flagged. During the IGY year, in the late 50s, United States did have a couple dog teams down at McMurdo. They only lasted a couple of years and gave way to gas buggies, if you will. When I was there in the mid-60s, visiting Scott Base, they had about 40 dogs out on the ice with small kennels and chains. This is our dog team, McMurdo Station in the background. That was from early or mid-50s years. Today, they still use sleds, but they use an ATM type vehicle to go. If a field party's out, they want to navigate, they need, of course, compass to get a bearing, and they need to know how far they've driven each day so they can do some dead reckoning and figure out where they are. So the sleds, of course, have that little wheel on the back. And the wheel has a counter every time it goes around once. So the number of revolutions times the circumference of the wheel will let them know how far they've gone. And then their compass will let them know their heading. The only problem is that the magnetic South Pole is about 200 miles away from the geographic South Pole. So your compass is heading you here, but the geographic South Pole is over here. And the deviation is, of course, known and can be logged, and that's an important part of navigation. even in the Northern Hemisphere, as we go, say, from America to Europe, there is a deviation between the North Pole and the magnetic North Pole, and you have to have a set of tables so that if you're dealing magnetically, you can adjust your readings to give you the geographic longitude, latitude positioning. So navigation is more than just pointing. You've got to have a nice up-to-date set of tables with deviations to get you corrected between magnetic direction and geographic direction. Some of the science efforts that were going on. Remember I showed you the picture with the C-17 coming in, looking across the edge of the ice shelf toward the Transantarctic Mountains. Over in the Transantarctic Mountains, there's an area called the dry valleys. There's enough thermal activity close enough to the Earth's crust upper level that it keeps these valleys dry. In fact, some of them even have small lakes. When I was on the ice, I got to meet Werner von Braun. He was down from Huntsville, Alabama, because they were checking out the dry valleys to see if there would be a good area to train the original moonwalkers. But finally decided that he could find a few places in the States that it would be a little more cost-effective to use. The geological field parties are, of course, looking for rock samples and fossil samples and that sort of thing. Here you see both. The composition of a rock sample and the identity of the fossil sample, you see, helps in validating the tectonic plate theory because they can find out where rocks in Antarctica used to mate with rocks in Africa or South America, and added greatly to the validity of the proof of the drifting of the plates apart. This is just wind erosion. I mentioned there's an ambient wind down there. This is at Palmer Station. There's a summer camp. They're out studying the glacier. Who knows doing what? These are a couple outlying stations at South Pole. Trying to remember what they were. Okay, the golf ball, if you will, is just a communication station. One lady was telling me about communicating with Antarctica from Miami, and this would have been one possibility, South Pole. The building is a meteor scatter nuclear radar equipment site, checking on stuff in the atmosphere somehow. This was a Viper, no, excuse me, this was a Spirex infrared explorer telescope, and this was designed to study the depths of the Milky Way specifically. These are all at the South Pole. And this is a Viper telescope. It views outer space during dark times. It has the ability to get a picture with very minimal light. And there are a lot of other exhibits that were going on at McMurdo and the South Pole, looking for neutrinos from outer space, that sort of thing. You know, neutrinos go right through us all the time. Back at McMurdo, here's an Antarctic cod in the science building. Here's a penguin diving down through a seal hole in the annual ice, probably looking for lunch. These seal holes are kept open as long as the ice is there for the seals, penguins to feed. The seals keep them open. This is a prefab field erected scientific station. You see it once erected, it's up off the snow, and it would accommodate about 20 people in a field party. Here's a scientific crew letting loose a weather balloon. Notice the balloon is very small, but the whole theory of the balloon is that the pressure inside the balloon increases with respect to the pressure outside the balloon as elevation increases. So by the time this gets at a high elevation and there's very little pressure from the atmosphere, the balloon's huge, it bursts and lands someplace. Here are the scientists getting ready to launch that balloon as a team. These are stored ice core samples. They're important to scientists for a number of reasons. For instance, you can go to any depth and find out the CO2 content of the atmosphere at that time in history. And a lot of people are interested in CO2 these days and carbon sequestration and so forth. I remember they dug a mine in Antarctica. It was down about 130 feet deep. And the people were pointing, and they said, here's the time of Christ. So scientists have some fun too. Okay, up north, it's Aurora Borealis. Down south, it's Aurora Australis, sunsets. Move along here. Here's a midday sunset along about April. This might be all you get to see in light. In the next 3 to 4 months, complete darkness. And then you see this again. Here are some clouds that only form at about 80,000 feet. They're the highest forming clouds there are. I'm trying to remember the name of them. Nacraceous clouds, 80,000 feet. Wow. Sunset. And again, this might be noontime. This is South Pole. This is the Aurora Australis. And of course, those are excess electrons following the lines of magnetic flux. Every line of magnetic flux has a conjugate point, North American, South American. Ham operators love those because their ham can travel. At McMurdo, as I recall, our conjugate point was up in Newfoundland. And you could talk to people there like they were next door. So the hams knew all about that. Mountains. This is the Trans-Antarctic Mountain Range. You see a little bit of rock uncovered there. Said about maybe 2 to 3% of Antarctica is snow-free. More mountains, glaciers. Dry Valley area. Here's a lake over in the Dry Valleys. Very unusual. Okay, one day I hopped a helicopter with some visitors and went up the coast of Ross Island, 20, 30 miles, and visited Scott's second hut and Shackleton's hut. As we were touring the second hut, we'd only been there maybe 15 minutes, the pilot came to the group and said, I am leaving. You're welcome to stay if you want. There was a whiteout rolling in. This is what a whiteout rolling in looks like. It's like pea soup. The pilots in a low-flying helicopter have absolutely no sense of whether they're right side up or upside down. Okay, here's an iceberg, process of Kavanaugh. Some glaciers. Here's the Beardmore Glacier. This is the highway that Shackleton traveled up on his adventures up into the plateau. Notice here on the left, top and bottom, and far left, you have 3 separate glaciers in confluence into a single glacier heading toward the sea. And you can begin to see some of the styrations of motion. Remember, ice plastic, these glaciers will move several feet a year. This even shows the movement a lot better. So all of the mountain system is nothing more than a glacier transport system for getting the snow and ice from the plateau down to the ocean. Okay, icebergs, calving off icebergs. This one sitting in some annual ice, brash ice, which usually the wind takes to sea. Here's a tabular iceberg. We had a lot of these break off from the Ross Ice Shelf right around Ross Island where I was, and I could look right down on them from 300 feet and watch them as they went out to sea. I put this picture in because it has a little colony of penguins there on that iceberg in the foreground. You have to remember, for these icebergs, 7/8 of them are below the water. And below the water, they tend to erode a bit. And so icebergs, not the ones that aren't too huge, will tend to tip over. And so sometimes you'll see the non-tabular icebergs. They're probably tabular icebergs that have tipped over. Okay, these formations in the foreground are called pressure ridges. When an immovable object faces the irresistible force, like the Ross ice shelf hitting Ross Island, around the island you have some under ice erosion, which thins the ice thickness, and then when the ice gets thin enough, it just bulges up into these pressure ridges. I must admit, it's fun to walk through these 30, 25, 30 feet high. And usually about once a year, we flag a safe route through the pressure ridges. And when congressmen or other distinguished visitors would come down, they were going to stay for 3 or 4 days. That's a lot of time. We would send them over to the pressure ridges for half a day to hike the flags. Anything to, entertain them. Here's the edge of the Ross ice shelf. It's probably 30 feet high there. You got to remember, 7/8 underwater. On the left was the annual ice. Out on that annual ice, on the 6th of September, 1963, I was out there with a Dodge Ram pickup truck that we had at the plant, and I was driving around on the annual ice from tabular iceberg to tabular iceberg because I'd gone out to the ice runway to see an airplane take off for Camp Adair to set up the meteorological station for the first flights coming into Antarctica. So while I was out there saying goodbye to them, I just had a little fun. We had 2 penguins near McMurdo, the emperor penguin, which is waist high, about 30 inches, and the Adelie penguin, about 18 inches knee high. The scientists have gone wild and started studying the penguins by fencing them in. Penguins can move by either walking on their feet or pushing themselves on their belly with their feet. They jump off the ice into the water. You can see one penguin down there in the lower right in the water. Word has it that a bunch of penguins come to the edge of the ice. They push one in. If he comes up, the rest of them go in. That's one of those myths, like we give volunteers to winter over in Antarctica back in those days when I was there by telling them there was a woman behind every tree. There weren't any trees. Okay, rookery, icebergs, rookery. That penguin is master of all he surveys. Penguin egg. Okay, little seal pup. Remember, penguins, seals, and birds. That was it. This seal pup has a mom. There she is. These penguins, full grown, would be 600 to 800 pounds. I've been within 6 to 8 feet of one of these penguins, and they bark like crazy. And discretion being the better part of valor, I just backed up. This is a tern. You probably are aware of bird people. That terns migrate annually from the Arctic to the Antarctic. That's a long flight for a little bird. Okay, then the other kind of bird there, the second one is a petrel, and they catch a lot of thermals and spend a lot of time in the air. And then the Antarctic scavenge bird is the skua gull. These things are around like pigeons on a beach. They're very bold, very sassy, and if they don't like you, they'll bomb your head, bomb your shoulder, and you have to watch out when they're in the area. Another skua gull. Okay, from the nuclear power plant, I could look down into the ocean, and I'd frequently see a pod of 5 to 7 orcas swim by. This is a pod of 4 orcas, killer whales, if you will. Whales are mammals. They have to find a lead in the ice or a seal hole to stick their nose up and breathe every once in a while. How would you like to be the photographer taking this picture? There he is. Now, that little bitty ice floe that he's on, the whales have a technique for getting penguins off the ice so they can eat them. 2 or 3 of the whales will get abreast of each other, swim full blast toward that little ice floe, dive under it, and in this process, they perturbate the ice floe enough to tilt the penguins off the ice and then have lunch. Okay, close up here with a few historical sites. This is Hut Point as I knew it in the 60s when we first went down before New Zealand cleaned it up a little bit, repaired it. This is Cape Evans, and that's Scott's second camp. Hut Point was his first camp in 1903, and this is second camp in 1910. It was from this camp that he took off for the South Pole. And there's Hut Point as it is today. And you see up on Observation Hill in the background the nuclear power plant. That was my home for 14 months. Okay, this is also Scott's hut. And this is Shackleton's hut, 1907 to 1909, between the 2 Scott expeditions. Shackleton, as I recall, was the gentleman, Englishman, who tried to get the South Pole with ponies. Dogs seem to work better. There's a crew of a C-130 Hercules. These are Air National Guard people from Schenectady, New York. I like this picture because it shows the ski configuration on the front wheel and on the midship wheels going back. You can see how hefty they are to aid in those planes landing on the runways we have in Antarctica. This is the South Pole. Remember I told you there was a silver pole, the ball they put on that pole for occasions. Would you believe it if I told you that these were 6 United States senators and your tax dollars at work? And the next day or two, these gentlemen might be climbing pressure ridges to kill a half a day. Okay, I've run out of time. I've run out of slides. This is Antarctica. Up here on the table, I have some mementos from Antarctica. You're welcome to come up here and browse, and I'll be here as long as anybody wants to ask questions. Phyllis, your ball game.
Okay, well, I have one. I learned some years ago that the Antarctic Treaty would exist only for a time certain and that it was due to expire. Do you know anything about the treaty and what happens after the treaty is expired?
I don't know, but it's still in force. Now, after the original treaty, there were a couple score of other countries that signed on as sort of associate members. So the treaty became very popular, well used, and I think we would be in big trouble if the Antarctic Treaty expired because there's too many countries, sovereign claims in Antarctica that overlap, and it would be a real mess. As I say, about 7 countries claim the South Pole. Now, what do countries do to set forth their sovereignty? One is to occupy. Well, we've been the only occupants at the South Pole for 70 years. The other is to declare by putting your flag up there. Well, you saw our flag up there. Another one is to issue stamps and have a post office there. We have done that. Antarctic stamps up here. So has New Zealand. So you see, with some of our allies, we'd be in a messy situation if the treaty were to lapse.
The UK has a postal service, a post office with 2 enterprising fellows in an island off the coast of the Antarctic Peninsula. But anyway, questions? Yes, Walter.
Thank you very much, Will. That was very interesting. Looking at that picture of the airplane, it looked like the skis were firmly attached. How do they retract those so they can land in New Zealand?
My guess is they take the skis off in Antarctica because you don't need skis to land at the well-groomed ice runways, either annual or up on the annual ice, the ice shelf. Um, I've seen planes land and take off with wheels. For instance, in the 60s, 70s, the main transportation plane to and from Antarctica was the Super Connie. Remember the three tails? And they would land with wheels, charter jets down from Christchurch. So that's not an issue. The only issue is to see that they're off before you go back to New Zealand.
I have a question about the fuel that they use for the ATVs. Why did they not use electricity rather than gas? And where do you keep the gas? You know, if you,
Phyllis,
since-
can you help me out? I couldn't catch it.
She was saying that you have gasoline-powered ATVs, for example,
Yeah.
and that sort of ties into a question, are they still using the nuclear plants to produce electricity? And if so, why aren't they running electric motors instead of
Yeah,
gas?
got it. At McMurdo, there are a number of large ground level tanks for petroleum, either diesel fuel, heating fuel, gasoline, and they can be canned and stored on the sled, and the field party will have gas for their ATV. It's just like being here, you know, you have everything you need because you bring it.
Yeah.
They are wrapped and electrically, you know, and when those pipes freeze, you're in deep kimchi. Lots of trouble. Yeah. Again, when I was wintering over, we didn't worry about pipes. The only pipe we had was a pipe from the ocean up to the distillation plant at the nuclear power plant. We had a 16-stage evaporative distillation plant that lowered the pressure at each stage. More steam would come off, you might say, from the seawater, and we would collect the steam, condense it, and send it down for drinking water. And when it was used down below, it just got put in a 55-gallon drum somehow and sent out to sea. So the brine from the distillation process, we'd bring up 10 parts from the ocean. 1 part would become fresh water, 9 parts would go back to the ocean. And that was the only pipe we had when I was there. The rest was all heat within your building.
Well, this just makes me want to go.
Well, the last I knew, the logistics support at McMurdo was being performed by Raytheon, the contractor. And you could go as a cook, maintenance person, housekeeper, you know, whatever. So,
I think this was a first-rate presentation. I thank you for that. And my comment is that a number of years ago, I heard a scientist from Whitney Lab, which is a satellite community campus for UF, and he was talking about his time at what he called Science City there in Antarctica. And one of his photos showed 3 people licking icicles. And you wonder, well, why would that be part of a scientific experiment? Well, the ice they were licking was 300 years old. So that's
yeah. Well, they did
other
other
questions?
crazy things. For instance, at the South Pole, they had a sauna. And they used to love to go in the sauna and then run out on the ice. Now, a sauna would be, you know, up around 200 degrees. Remember, though, at the South Pole, you can't bake. The pressure's not the same. The boiling point of water is much lower than 212. So whatever the boiling point of water was, the steam in their sauna, they would then run outside when the temperature was about minus 123. So add those 2 temperatures together, minus 123 plus whatever the boiling point was together, and they were members of that club. I'm very proud of it. Stupid.
Thank you. Very interesting. I wonder what research interests bring people to Antarctica. Is it to study the ecology, the environment, or is the atmosphere, the setting conducive to certain scientific work?
Okay, let me just refer to my notes here for a minute so I don't miss any. During the IGY year, for instance, simultaneous observations were conducted primarily in 11 fields of Earth science, and non-Earth and solar science: aurora and air glow, cosmic rays, glaciology, gravity, ionospheric physics, latitude and longitude determination. We did talk about the deviation there and so on. Meteorology, oceanography, seismology, and solar activity. Those were the agreed to amongst the nations areas of data collection. And then the data during the IGY year was exchanged between all the member nations.
Since this is an NSF-funded project for the US, don't they have to be approved? Don't the research studies have to be approved by the NSF then? Would they?
Oh, yes, unless you wanted to privately fund something. Yeah, the universities and professors and graduate students are typically the ones that come to Antarctica and compose the field parties. Some of the professors have been down there year after year, and know the Antarctic well.
Thank you very much. This has been great. I just wanted to make a comment on the ask the question on electric vehicles. Extreme cold has a real problem with electric vehicles with the batteries, and so that's one of the reasons they don't use them too much.
Yeah, currently that would be an issue. I doubt if there's a single electrical vehicle in Antarctica today. No, due to practicality.
Any other questions from the engineers in the room? I see a few. Okay, well, thank you very much. Thank you. Oh, how about Zoom? Do we have Zoom questions? Nothing, okay.